This question says, write the balanced half reaction for the following redox reaction, and it may occur in acidic or basic solution. So one thing you might want to do first is determine whether or not it's occurring in acidic or basic solution. So if you see OH minus, you know it's basic. If you see H plus, you know it's acidic. So in this case, it's OH minus. Now we need to figure out what's going on as far as oxidation and reduction are concerned. I'm going to start with iron because it's first. Over here it's plus 3. Over here it's plus 2. As it's been in several other videos, there's the mnemonic device Leo the Lion says Grr. Losing electrons is oxidation. Gaining electrons is reduction. Well, if something goes from plus 3 to plus 2, it gained an electron. So this is reduction. Finding the oxidation, or what's being oxidized, is a little bit more challenging. But one thing I notice is that in both the products and reactants, we have oxygen, which is always minus 2. And we have hydrogen, which is always plus 1, or at least most of the time. And we have nitrogen. So a good candidate is nitrogen, because the hydrogens and the oxygens are kind of going along for the ride in this basic solution. So let's take a look at the nitrogen. Well, in NO2, it's neutral, so we have N plus 2 times the oxidation state of oxygen, which is minus 2, equals 0. So N minus 4 equals 0. N equals plus 4. So in NO2, N is plus 4. What about in NO3 minus? Well, we have N plus 3, because there's 3 of them, times minus 2 equals the overall charge, which is minus 1. N minus 6 equals minus 1. Add 6 to both sides. N equals plus 5. So it goes from plus 4 to plus 5. And here, we have lost an electron, so this is oxidation. So it asks us for the reduction one first, and it's actually probably the easier one. We have iron 3 plus going to iron 2 plus, so it must gain an electron. Now, if you wanted the other half reaction, you could probably just pick out everything else that's not iron 3 plus and iron 2 plus and write it down, and that would probably work. But for the interest of practicing for a basic reaction, let's take a look at this. And let's do this out completely, just so you have another example of this, like on the previous video in this playlist. Let's look at this. We have NO2 gas, and it's forming NO3 minus aqueous. In this case, I'm going to write this just a little bit lower. So it's NO2 gas, and it's forming NO3 minus aqueous. In this case, this is plus 4, and over here this is plus 5, so there must be an additional electron on this side, because it goes from plus 4 to plus 5. That electron had to go somewhere, so that's going to be written over here. Now we need to balance it. Well, the first thing I notice is we have one nitrogen and one nitrogen, but we have 2 oxygens and 3 oxygens. Well, where do we get oxygens from? They come from water, liquid. So we need one water over here because we need an additional oxygen. Well, if we add a water, then we need to add hydrogens on this side, and we assume as if this is an acidic solution. So over here we add 2H plus aqueous, like so. So we added water to balance out the oxygens, we added H plus to balance out the hydrogens that we had to add from the water. But this is a basic solution. We knew that because we originally found out that it had OH minus. So we can't leave H plus in this basic solution. So what we need to do is we need to add the appropriate amount of hydroxides to both sides. Well, in this case, we want to add 2 OH minuses over here, and we want to add 2 OH minus over here. So we want to add 2 hydroxides to both sides. These will cancel out and form water. So let's write this out one more time. We have NO2 gas plus H2O liquid plus 2OH minus aqueous yields NO3 minus aqueous. The 2 OHs and the 2 H pluses form 2 waters plus 2 H2O liquid plus an electron. There's 1 water on this side and 2 on this side, so we cancel those out. And finally, for our half reaction, we get NO2 gas plus 2OH minus aqueous yields NO3 minus aqueous plus H2O liquid plus an electron. So this is our oxidation half reaction in basic solution. Note that if it was an acidic solution, we never would have added these OH minuses, and that would have been our half reaction if it was an acidic solution. So that is essentially how we figure this out, very much like the previous problem on this playlist.